Hello, I'm Jeff Shallcross, President of Nationwide Boiler. The video you're about to see tells the story of the Nationwide Boiler Catastack, a selective catalytic reduction system, not too much different from what may be on your car or that is installed in power plants throughout the United States. The development of the Catastack began in 1999. We had just finished converting our entire rental fleet over to low NOx emissions. We realized at that time that that was not enough and that new regulations were on their way. We wanted to achieve a goal of having a clean air rental fleet. So we embarked on a study of what technologies and methods may be able to reduce the emissions from levels of 30 ppm NOx down to levels of 6 ppm NOx. So after several months of evaluating different technologies and methods, we determined that the SCR was going to do the job. We attempted to come up with a design and system that we could deliver that was cost effective, efficient, have minimum operator intervention, and be very reliable. I think we've achieved that goal. So over a period of years, we developed this Catastack, selective catalytic reduction system, and applied it to our rental boilers. And it was very successful. We decided that customers may want to install this equipment themselves. And so I think we've achieved our goal of a low emissions, very reliable, cost-effective solution that our customers will like. You're about to meet Larry Day, who's our Vice President of Sales and Marketing, who has been spreading the good news about our Catastack. He's about to take you on a tour of the inner workings of the Catastack and show you some installations in California. Thank you.
Thank you, Jeff. Industrial steam boilers are one of the largest energy consumers in the United States. Over a third of these units fire natural gas, and even though natural gas is a clean burning fuel, they still produce NOx, which is a major contributor to ozone and smog pollution. Since 1990, when the Clean Air Act was enacted, industrial boilers have become a target of air districts for reducing NOx. The South Coast Air Quality Management District in Southern California leads the nation in their aggressive NOx reduction standards. They now require boilers to have burners and/or back-end equipment that produces NOx under 10 ppm in most requirements. Also, the Central Valley in California and the Bay Area have followed suit. Thus, for over 20 years, California has been tightly reducing NOx emissions on industrial boilers. We expect this aggressive emission reduction to carry out throughout the rest of the country. In fact, it is already in effect in parts of Texas and New Jersey. In this video, we're going to show you how Catastack works, some installations of a Catastack both in a horizontal and a vertical configuration, and also some testimonies of customers who have installed Catastacks in their own existing facilities. Before we do that, I'd like to point out some of the features of the Catastack. This is a proven technology. Catastack has never failed a third-party source test. It's also an easy retrofit, much like installing an economizer in your exhaust stack. The simplicity of the operation allows your burner to operate like it did before the installation of the Catastack. In other words, it doesn't affect flame stability, load response, or turn down. Also, the low pressure drop of the Catastack doesn't require any kind of fan changes either. The Catastack is also very efficient to operate. The cost of the ammonia more than offsets the cost of running a high horsepower fan in most high FGR burners. The Catastack can also be reused on a future boiler down the road if you ever want to switch boilers. Those are just some of the features of our Catastack. Now let's go back to our manufacturing and assembly facility and take a close look.
Catastack consists of three primary assemblies. These are the ammonia injection module, the reactor module, and the ammonia supply skid. There are two other Catastack components, the transition modules that adapt the reactor module and ammonia injection module to your exhaust stack, and a thermocouple assembly that monitors exhaust stack temperature. Let's take a close look at the three major components and see how they work. First, the ammonia injection module. This unit, mounted in the boiler exhaust stack, contains a manifold with multiple injector nozzles. Ammonia gas flows through the manifold into the boiler exhaust gas stream at a regulated rate. The exhaust gas, with its high NOx concentrations, mixes with the gaseous ammonia and flows to the reactor module, the second major component and the heart of Catastack. The stainless steel reactor module is encased in a protective steel enclosure. It features a lateral flow design to minimize pressure drop, in the range of about 1 to 2 inches of water. The reactor module contains the low-temperature catalyst manufactured by CRI Catalyst Company, a subsidiary of Royal Dutch Shell plc. As flue gas flows into the reactor module, gas molecules come in contact with the catalyst. The design of this module, with the large catalyst surface area, provides optimum contact between the flue gas and the catalyst, resulting in the highest level of NOx conversion. The result? The NOx ammonia mixture are converted into harmless water and nitrogen. The reactor module and the injector module are conveniently sized for shipment to the job site. There, they are joined together by means of a mating flange and attached to the exhaust stack with appropriate transitions. We'll see more of this installation process in just a minute. The third key element of a Catastack system is the ammonia skid. The ammonia skid contains all of the required controls and instrumentation needed to operate the Catastack system. This unit controls the ammonia flow into the flue gas stream to match the natural gas input of the boiler burner. This simple and foolproof way of controlling ammonia flow eliminates the need for complicated and expensive NOx measuring systems. In this unit, there are 3 standard gas storage cylinders, or bottles, each holding up to 150 pounds of gaseous ammonia. Installation of the bottles is simple. They are easily moved by 2 men without the need for special handling equipment. By limiting the total storage capacity to less than 500 pounds of ammonia, there is no need for special use permits or hazmat or emergency safety plans in most jurisdictions. The manual flow valve is quickly attached. With the reactor module, ammonia injector, and ammonia skid properly installed, NOx emissions from package boilers up to 250,000 pounds of steam per hour are reduced to below 5 parts per million. Now, let's take a look at a couple of typical Catastack installations. First, a horizontal installation on a new boiler at the Del Monte plant in Modesto, California. This installation of a new 50,000 pound per hour, 275 psi package boiler is one of, if not the, most fuel-efficient, cleanest burning boilers in the country. It has been certified at better than 95% fuel efficiency and less than 2.5 parts per million NOx. The first step in assembling the complete exhaust system of this boiler is the mating of the ammonia injection module to the boiler exhaust flange. Here you can see technicians welding the boiler exhaust and ammonia injection module flanges together. The next component to be installed is a transition unit that redirects the boiler exhaust 90 degrees. This is done to provide a compact footprint for the complete boiler installation. Gasket material is installed between the mating flanges to assure that no exhaust gas leakage can occur. Once the gasket material is in place, the 2 components are bolted together. The ammonia injector module and the transition unit are bolted together rather than welded, as was done with the boiler to injector module connection. The next item to be installed is an expansion joint. Expansion joints are comprised of 2 metal flanges connected by a flexible, high-temperature fabric. Expansion joints are required in horizontal installations only and are needed to accommodate thermal expansion and contraction, as well as seismic disturbances. After gasket material is applied, the expansion joint is mated to the transition unit. In this installation, a filter module is installed to prevent any particulate matter from impinging on or contaminating the catalyst in the reactor module. A viewport in the side of this unit permits visual inspection of the filter medium. The next item installed is the reactor module containing the catalyst. Another transition piece is installed. In order to achieve maximum fuel efficiency, an economizer is installed, providing a fuel savings of up to 10%. A final transition piece is installed. One more expansion joint is added. And finally, the stack is lifted into position and bolted to the last expansion joint. The first component, the ammonia injector module, was hoisted into position at 7:30 in the morning. By 10 o'clock that same morning, the stack was bolted in place. Only 2.5 hours had elapsed. Now, let's take a brief look at a vertical catastack installation. In this case, the catastack is installed in the stack of an existing boiler at a food processing plant. First, the current stack was removed. A pre-assembled ammonia injector module, transition unit, and reactor module housing are hoisted into position. This system was designed to fit within the restricted available space. To accomplish this, 2 small reactor modules were installed in one housing, rather than the customary single module. This arrangement provided sufficient catastack capacity to support the exhaust from a 125,000 pound per hour boiler while staying within the available space. Finally, a transition unit is installed on top of the complete reactor module assembly. This is a photo of another installation where the reactor module, transition module, and stack were all pre-assembled and hoisted into place. Now let's hear what a few catastack customers have to say about catastack. Our catastack passed our source test at 5 ppm NOx and no more than 2 ppm NH3. I'm so glad we went with this instead of a low NOx burner. The unit does everything it is supposed to do and more. Leland McFerrin, H.J. Heinz Company. The catastack unit was very easy to install, easy to operate, and easy to maintain. Overall, it is a totally painless way to meet difficult emission requirements. Gordon Judd, NRG Energy. Catastack enabled us to meet the most demanding NOx emission limits in the country as required by the South Coast Air Quality Management District. It easily passed the third-party source test and performed reliably with minimum operator attention and virtually no maintenance. Larry Clark, ConocoPhillips. The Catastack SCR system allowed us to easily meet the stringent emission requirements of our local air board. It ran very reliably during the entire project. Rick Bonner, Tesoro Petroleum. The Catastack was easy to install and has operated flawlessly for over 2 years. It had the lowest capital cost and continues to have minimal operating cost. It has consistently reduced our NOx emissions to well below the required level. Tim Durham, Ingomar Packing Company. Nationwide Boiler, the rental boiler industry leader and the company that pioneered trailer-mounted package boilers 40 years ago, is proud of the success of Catastack. It has proven to be an efficient, cost-effective, and practical solution to reducing NOx emissions from package boilers to below 5 parts per million. For more information, technical specifications, or to talk with one of our sales engineers about Catastack, please contact us at www.nationwideboiler.com or call us at 1-800-227-1966.